Jai Hind everyone. My name is Amrita Bhatnagar. I am from CSE department of AKGEC. Today I am going to explain a very important topic, normalization from database management system. You can see these are the outline of this lecture, where firstly we will understand what is the meaning of normalization. Then next we will see why do we need normalization. And then we will see the anomalies in the database. What are the different anomalies in the database? Then we will discuss about the first normal form, second normal form, third normal form, and BCN of normal form. Okay, so we will start with the introduction of the normalization. You can see here, normalization is a process of organizing the data in the database. Normalization is used to minimize the redundancy from a relation or a set of relations. It also used to eliminate undesirable characteristics like insertion, update, deletion, anomalies. Normalization divides the larger table into smaller tables. The normal form is used to reduce the problems or anomalies in the table. So we can say there are some different type of anomalies our database. Anomalies means there are some problems in the database which can be removed with the help of which is known as a normalization. This is the process of normalization. By the help of normalization we can remove the anomalies from the database. Now we will see why we use this normalization. The main reason for the normalizing the relations is removing some anomalies. Failure to eliminate anomalies leads to data redundancy and can cause data integrity and other problems as the database grows. Normalization consists of series of guidelines to help us to creating a good database structure. So we can say normalization is a very important process for the database. It will remove the all anomalies or problems in the database which can be a reason of the data redundancy. Now, what are the anomalies in the database? There can be three types of anomalies. First one is the deletion anomaly, and third one is the updation anomaly. In the insertion anomaly refers to when one cannot insert a new tuple into a relationship due to a lack of data. So in the case of insertion anomaly, we cannot insert the data in the table because of some lack of data. So there is a problem in the insertion into the table. So this is the first anomaly in the database which can be removed by the help of normalization. Second one is the deletion anomaly. Deletion means we will delete or remove some particular data from the table. The deletion anomaly refers to the situation where the deletion of the data result in the unintended loss of some other important data. So when we want to delete a particular record from the table, but that record will remove, but it will remove also some important data from the database also, which is a problem in the database, which is known as a deletion anomaly. And next is the updation anomaly. In the update anomaly is when an update of a single data value requires multiple rows of data to be updated. So updation cannot be possible because it can update all the multiple values of the rows, so which is not required. So these are the three anomalies in the database which can be removed by the help of normalization in the table. In the case of normalization, we will check all the normal forms in the tables, and we will decompose the table to create a new normal form. So firstly we will start with the first normal form. First normal form. A table is referred to as being in its first normal form if atomicity of table is 1. Now the question is, what is the meaning of atomicity? This is the new word, atomicity. Atomicity means when we use only single value in a cell. If we have multiple value in a table or in a particular cell, then the table is not in the first normal form. So we can say that here for a table there is a need of atomicity to be in a first normal form. The first normal form, this allows the multi-valued attributes, composite values and their combination. So for the first normal, we have to remove multiple values and composite attributes from the table. This is the basic requirement for the first normal form. Now we can see an example. You can see here, this is the example of the student table. So we can see here we have 4 columns here: roll number, name, course and age. Okay, and we have 6 record here. 6 tuples are there. And now, but you can see here in the case of course, we have more than 1 values in the table, C and C++. Again, you can see here in the case of Sahil, studied 2 courses, C and C++. And in the many tuples, you can see here there is a multiple values here, which is not required in the first normal form. So we have to remove this problem. We have to create an atomic data into the table. So how we can create atomic data in the, you can see here. Now this table is updated, and now you can see here we have now 2 rows for the Rahul, and in the each row course will have C, and in the other row course will have C++. So we have created 2 different rows for the different courses. Okay, so in this way we can say in this table now we have atomic data, because now we have only single valued rows. We don't have multiple values here. So now this table is in the first normal. So first normal, for the first normal form we have to remove multi-valued values in the cells, and we should have only single values, and we should also remove composite attributes also if we have composite attributes. Now in the second normal form. Now for the second normal form, the first condition is it should be in the first normal form. Okay, and when it is in the first normal form, then we have to check there should not be any partial dependency in the table. There should not be a partial. Now the question is what it means. What is the meaning of partial dependency? To understand the meaning of partial dependency, for example, we have a candidate key AB in a relation, and this is the functional dependency. What it means? C is totally dependent on AB, or AB is a candidate key. But if there is another dependency where C is dependent on the B, what it means? B is a subset of candidate key, and now C is also dependent on the B. Now there is a partial dependency. It is known as a partial dependency, which should not be in the second normal form. We have to check the tables. It should not have contain partial dependency, and if it is having partial dependency, then by the decomposing the table, we have to convert it into the second normal form. Okay, the partial dependency here means the proper subset of the candidate key should give a non-prime attribute. What? Okay, so now we see with the help of an example here. Now you can see here, this is a table. Here we have customer table where cust ID, store ID, store location. We have 3 attributes here. Okay. Now we can see here what are the dependencies here. Here, if for example, if we have candidate key, customer ID and store ID. This is a combination of 2 attributes, customer ID and store ID. Now you can see here, these are the 2 keys, 2 functional dependency here, where we have customer ID and store ID is a candidate key. Okay, and the store location is a non-prime attribute. Now what the question is, what is the meaning of prime and non-prime attribute? The part of the candidate key is known as a prime attribute, and the attribute which are not the part of the primary key is known as a non-prime attribute. In this case customer ID and store ID are the prime attribute, and store location is the non-prime attribute. So now you can see here store location is totally dependent on the customer ID and store ID. Now store ID is a subset of the customer ID and store ID means candidate key. Store ID is the subset of the candidate key, and store location again dependent on the store ID. Or you can say that store ID uniquely identify the store location. So which is a partial dependency, because store ID is a subset of the candidate key. So we can see this table is not in the second normal form. It is because we have all the single valued here, that's why it is in the first normal form, but now it is not in the second normal form because it have partial dependencies here. Fine. Now, how to remove this partial dependency? So, in the case of normalization, when we want to convert a particular table into the particular normal form, we have to use decomposition rule. So, we have to decompose the tables for normal forms. Fine. Now, we have to convert this table into the second normal form. So, we will decompose our table. So, for the decomposition, what we will apply for decomposition, we will decompose the table in this way so that store ID and store location will be in the one table and other attributes will be in the another table. You can see here example. Now, this is the decomposition in the second normal form. You can see here customer ID and store ID is in the first table, and second table store location and store ID. Because we have this store ID and store location have a partial dependency, so that's why we have decomposed the table into the another table. So these now the partial dependency is not in the both tables. You can see here we have two dependency now. The store location is dependent on the store ID, and in this case store ID is dependent on the customer ID. Or we can say that this is a candidate key only, not dependent to each other, but these two are both are combination of candidate key. So now partial dependency is removed from the table. So now this table is decomposed into the second normal form. Fine. So next is the third normal form. For the third normal form, again tables should be in the second normal form. What it means second normal form? It should not have partial dependency. Fine. Now, and for the third normal form, there is another condition which is known as a transitive dependency. Now, we should understand what is the meaning of transitive dependency. You can see here, if B dependent on A and C dependent on B, then what it implies? It implies that C is indirectly dependent on A. So, this is known as a transitive dependency. So this transitive dependency should not into the table. If it is in the table, then we have to decompose the table to remove this transitive dependency. So we should understand for the third normal form, we have to convert table into the second normal form. Then we have to remove the transitive dependency from the table. The third normal form ensures that the reduction of data duplication, it also used to achieve data integrity. So it can remove many type of different problems, just like data redundancy from the table if we have third normal form in the table. Now we will see the example how we can convert a table into the third normal form. Now you can see this is a student table. You can see here we have here 5 attributes: student ID, name, sub ID, sub and address. And you can see here we have single valued cells, so that we can see here we have first normal form because we don't have any multi-valued cell here. The first normal form is maintained here, and for the second normal form there should not be any partial dependency, and for the third normal form it should not have any transitive dependency. So we will see the dependencies here. You can see here we have in this case we have 2 dependency. Sub ID is dependent on the student ID, and sub or subject is dependent on the sub ID. Okay, so from these 2 dependency we can implies sub is dependent on the student ID, which is a transitive dependency, which is not required in the table. But we don't have any partial dependency here, so that we can say that this table is in the second normal form. But it has a transitive dependency, so that it is not in the third normal form. To convert this table into the third normal form, we have to use decomposition technique, and we will divide the table into two forms. Now we can see here, this because of this dependency, we have transitive dependency here. So we will decompose the table in this way, so that these two attributes will be in the different table. So we can see here how we will convert our table into the third normal form. You can see we have decomposed the table into these two tables. First table, you can see here, sub ID and subject, we have kept this table into the different table, these two attributes, because subject and student ID create the problem here. So that we have subject and sub ID here in the different table, and in the another table we have address, subject ID, name and student ID. So in this way, now the problem is dissolved, and we have removed the transitive dependency from the table, so that by the help of decomposition we can convert any particular table into the particular normal form. Fine. Now the next normal form is BCNF, or Boyce Codd normal form. Boyce Codd normal form is also known as 3.5 normal form. It is a superior version of third normal form and was developed by the Raymond F. Boyce and Edgar F. Codd to tackle certain type of anomalies which were not resolved by the third normal form. So that this normal form is known as a 3.5 normal form, because this is very much useful than the third normal form, because it have resolved the many problems which were not resolved by the third normal form. The first condition for the table to be in the Boyce normal form is that table should be in the third normal form. So firstly we should check in the table it should be in the third normal form. For checking the third normal form, we should not have any transitive dependency. Firstly, in the first case, first normal form, we should have atomic values. What it means? We should have only single valued rows. Second, in the case of second normal form, it should not have partial dependency. And third normal form, it should not have transitive dependency. If the table is in the third normal form, then we can convert this table into the BCNF normal form. To convert the table into the BCNF, what should we check here? The condition you can see here. For the third normal form, we should check that every dependency should have a super key of a particular table. If we have any dependency, and the right side of the dependency should have super key. This is the condition for the BCNF normal form. So we have to check for the BCNF, we have to check the tables for the BCNF normal form. It should have all the dependency super key. Now we will see an example for the BCNF also. Now you can see here, this is the table. We have a table where we have three attributes: student, subject and teacher. Okay. So now these are the functional dependency for the table. So you can see here we have that student, teacher in the combination are candidate key. This is given in this table. Candidate keys are the student, teacher and student, subject. These are the two candidate keys in the table. Okay. So firstly we will check first functional dependency. So first, subject is dependent on the student and teacher, which is a super key. Criteria fulfilled, because this is a super key or candidate key. Now teacher is dependent on the student and subject. Again, student and subject, again a candidate key. So again criteria is fulfilled for the BCNF form. And the next one is the subject is dependent on the teacher, but teacher is not a candidate key. So in this case dependency is not fulfilling the criteria for the BCNF. So that we can say that this table is not in the BCNF form. Fine. So for convert this table into the BCNF form, we have to decompose the table into two tables, and we have to remove this particular functional dependency. Okay. So how we will remove this functional dependency? The above relation is in the third normal form since there is no transitive dependency. A relation R is in the BCNF if for every non-trivial functional dependency x to y, x must be a key. The above relation is not in the BCNF because the functional dependency teacher to subject teacher is not a key. This relation suffers with anomalies. So we will try to convert into the BCNF. But what is the problem in if we have this anomaly in the table? For example, if we try to delete the student Subbu, we will lose the information that R Prasad teaches C. So when we want to delete a particular record, then record will be deleted, that's okay, but it will delete the more important things also from the table, which is a very undesirable condition. So we have to remove this deletion anomalies from the table. So in this case, we have to remove that functional dependency which don't have super key in the right hand side. Fine, which is this functional dependency. So, teacher to subjects violates BCNF since teacher is not a candidate key. X to Y violates BCNF. Then divide R into R1 XY and R to R minus Y. Okay. So, this is the rule to decompose the tables into two form. We will keep these X and Y attributes in the same table, and in the another table we will keep R minus Y attributes. Fine. So R is divided into two relation R1 and R2, where R1 have teacher and subject attributes and R2 will have student and teacher subject. Okay. So you can see here these are the two decomposition of the table. Now R1 will have teacher and subject, where we have the dependency teacher and subject is dependent on the teacher. Okay, where here the teacher is the super key. That's okay. Now in the another table we have student and teacher, where student and teacher both are combinedly candidate key. You can see here student teacher are the candidate key. So in this case student teacher are combinedly candidate key. So now these two tables are in the BCNF form. So we have discussed 4 normal forms in this lecture. First normal form, second normal form, third normal form and BCNF. Thank you.